So that's kind of a neat situation. And that brings us to the stomach. And the stomach lies, when we look at the stomach as a whole structure, it lies in the upper left quadrant of one's abdomen, just below the diaphragm. It secretes 2 to 3 liters of gastric juices each day. That's a lot of liters. That's a lot of volume. Again, a liter is approximately a quart, so it's 2 to 3 quarts gastric juices. The gastric juices pH is 1.5 to 2, so that's very, very acidic. So that has a consistency of water and a lot of hydrochloric acid, which brings the acidity to it. It also has a lot of mucus in it, and then it has enzymes in it, pepsin, and the pepsin is a protein splitting enzyme. And that protein splitting enzyme combined with the HCl, the acidity, liquefies the food chemically into a paste, and that paste is more, it's more liquid, and then it's called a chyme. And then chyme is also mixed mechanically, so we have chemical digestion and mechanical digestion in the stomach, and it's mixed mechanically by the muscles contracting in different directions. And in the stomach we have a third muscle layer. We have 3 muscle layers. We have a diagonal muscle layer as well. And then slowly, as the food gets processed, it moves from the esophageal end here down to the duodenal end, which is then the next structure. That's the small intestine. It does that, takes about 1 to 5 hours, depending. The more fatty the food is, the longer it takes. So fat prolongs that process. When we look at the gastric juice, we have to sort of think about secretion of the gastric juices. We want to secrete the juices that digest food when the food arrives, not when we, not randomly all over the place. So we have ways to organize that, and we have different phases that we can describe. We have first a phase that we mediate through the nerve. It's called the cephalic phase, and it's mediated through the vagus nerve. And it is initiated when we smell, when we see, or when we taste food. So when we actually sit on the table or we start thinking about food, we start getting hungry, that's when the cephalic phase takes place. And then food itself triggers the secretion of the hormone gastrin, which reaches the cells that secrete the HCl, the hydrochloric acid. That's right here, the HCl, the hydrochloric acid, and that reaches that through the bloodstream, and so that's actually a hormone, and so that's the gastric phase when the food shows up. It's a nice feedback. And then the first part of the intestine, which is the duodenum, adjusts the chyme coming in from the stomach. So after the stomach we go into the duodenum, and that adjusted the chyme coming in by either an inhibiting hormone or a promoting hormone, depending on how much it can handle. And so that's also then working with that digestive process within the stomach. And that's then known as the intestinal phase. The inhibiting hormone that the duodenum can secrete is the secretin, and the promoting hormone is more gastrin that gets secreted. So that gets into sort of the physiology of the gastrointestinal system, which is very interesting. Is not that complicated. A lot of it has to be with start and stopping, and then with breaking down the food molecules, and making sure the food doesn't pass too fast or too slow. And so it becomes overwhelming in terms of how many hormones there are. That's why we don't go through them all singly. But, you can look those up. Some will digest proteins, some will digest fats, and some will digest carbohydrates, and so on. But those are the main ones. When we look at the stomach in terms of an anatomy, sometimes we get butterflies in the stomach. But the bag-like muscular organ is consisting of an inlet, which is called the cardia, which we get in there, a fundus, which is an area that is reaching above the inlet. So sometimes there's gas accumulation up there. You can see that here. There's gas up here in the stomach. And then we have the main part, that's the body. And at the latter end, at the distal end, we have a pyloric antrum. An antrum means a four-chamber. And then we get into the pylorus itself, and pylorus is the canal here. Pylorus is a gatekeeper, that's what that means. Here's the text. The fundus can be seen as a dome on the left of the cardia, an air bubble, swallowed air often outlines an X-ray on an X-ray. And then we have the greater curve and the lesser curvature here. And the greater curvature is on the outside, it's longer, the left side, and the lesser curvature is the one on the right side, because the stomach lies in the left upper quadrant of the stomach, right underneath the rib cage there, and that's the lesser curvature right here. So that's how the anatomy of the stomach looks. Microscopically, we have, when we look at the inside, the mucosal surface, we show numerous longitudinal folds. We can see those with the naked eye, and those folds are called rugae. And in those folds, we have tiny holes that open into gastric pits. And then within those pits, we have multiple cell layers that secrete different things. So those are basically, those are glandular pits. We have deep laying, we have chief cells, and the chief cells secrete pepsinogen. And when you see an ogen, here it is, pepsinogen. An ogen, that means it's a GEN stands from Genesis. You remember the Bible, in the Bible is the creation. So that's a precursor. That's a non-functioning enzyme. Because the fact is, if you have an enzyme, pepsin digests protein. If we have an enzyme that digests protein, we have protein in our own cells, we don't want that around because that's going to digest our own body. And so we only want that functioning and active when we have food coming in. But if it's in an inactive form, we can create it ongoingly, and we don't have to be so concerned about it digesting ourselves because it's not functioning yet. And so then what makes it functioning actually in this situation is the cells, the parietal cells, because they secrete hydrochloric acid. And the hydrochloric acid makes the pepsinogen, right here, the H is from the acid, into pepsin, and then that digests amino acids, the peptide bond in amino acids. So that's kind of cool. The intrinsic factor is also created. That's important for vitamin B absorption, B12. And then more superficially, we have neck cells, and they produce a protective mucus. And the protective mucus we want to have laying around the inside here on the stomach, so that the HCl, the acidity, doesn't do any harm. The good thing is when we have a bacterial environment, an acidic environment of a 1.5 to 2, and we have bacteria coming in, guess what? A lot of that stuff dies right there. So that's a great part. Actually, it's a great part of the immune system if you think about it. So HCl doesn't just activate the pepsinogen, it also is bactericidal, and it kills a lot of bad stuff that we don't want in the system. Cool. So from there on we go to the small bowel. The small bowel, the small intestine, is about a 3 to 5 meter long tube. A meter is about a yard. And it starts at the pylorus, at the stomach, and it ends as we get into the large intestine by the cecum. We're going to get to that. The first part is the 12-finger gut. That's about 12 fingers long in terms of the fingers width, 12-finger width long. And that's called the duodenum. It embraces the head of the pancreas. Because the pancreas is actually not just, as we learned in the endocrine system, not just secreting insulin and glucagon, which works on the blood glucose levels. It also secretes pancreatic juices and enzymes into, as well as bile actually, into the duodenum. So much of the chemical digestion happens because pancreatic enzymes are chemical digestion enzymes. It happens right there, so which makes a lot of sense. We get the food, we eat it, we chew it up, we make it smaller, we start digesting the carbohydrates, we denature the protein, we digest it further, and now we have to make it as small as possible, that those molecules are absorbable. They need to be small enough to absorb. So the first phase of the small intestine still concerns itself with making chemically digesting macromolecules into microstructures, into monosaccharides, amino acids, and fatty acids. So that's what we do here. The jejunum comes next. The jejunum is then we have the ileum at the end there. The jejunum is a surface which is considerably extended by folds and then villi, and on top microvilli. Look at this. When you look at this, there's a lot of these up and down structures here. These increase the surface area greatly. And that's great because in this area we have a lot of absorption. So the mononutrients, the amino acids, the single amino acids, the single glucose molecule and so forth, the fatty acids and thus, they get absorbed in this part of the small bowel, in the middle part, in the jejunum. So the surface extension then decreases gradually as we get further away from the needing to absorb nutrients, but we absorb more and more just water. And that's more happening in the ileum, the final portion of the small intestine that then ends in the ileocecal valve, right in this area here. And that's what we're going to go next. But first, we're going to look at absorption. So this is when the small molecules get from the intestine into the bloodstream. The submucosa in that area of the intestine, in the jejunum, creates about 600 folds that project about 1 centimeter into the lumen, into the space. So that's just these wiggly structures that you saw on the previous slide. And then from there we have tiny finger-like projections, if we want to give them some measurements, 1 millimeter high about and 0.1 millimeter in diameter. Tiny stuff. And those villi contain capillary networks and a central vessel here, a central lymphatic vessel right here. So they go up and down. See, this is where it's rolled out, and you can see these things, these folds. But then inside the folds you get these little nibbly things coming off, and this is one of those little nibbly things. That is the villi, and in there you have a blood vessel, and that's where we have enterocytes, and those are simple columnar epithelial cells, and they line those villi, and they from there display actually microvilli on top of them. So that's like right here. You see that? That's one of those columnar cells, epithelial cells. They're all cells next to one another, and from there you have microvilli coming up off. Cellular extensions. And those microvilli they increase the surface area even more, and they actually display a lot of these enzymes. They hang around there, those brush border, then they call them brush border enzymes. And from here, this is the area where we have absorption. And then the food gets absorbed into those cells, through those cells, into the bloodstream. Or the lymphatic. So the water-soluble substances, they go into the bloodstream. So that would be the proteins and the carbohydrates. They go then first to the liver via what we know that is the hepatic portal vein, the hepatic portal system. So nutrients get first to the liver where they are processed. The blood is processed, and we can then use a lot of the stuff there. And plus, it's cleaned up as well. And fats go through the bloodstream through the lymphatic vessels. So those are the insoluble in water substances, the hydrophobic substances, and they go through the lymphatic system and be dumped into the vascular system near the heart, and then they get processed. So that's in short the absorption process here.